Hi, ladies and gentlemen. So today what we're going to be learning is about molarity, which is something new that we haven't discussed yet. So molarity is going to really just be the concentration of a solution. So remember, a solution is when we have an ionic compound that was dissolved into water. So we have those ions floating around in the water. And so we want to know how many of those ions or how many atoms or particles are in that solution. So we're using that to figure out like the moles inside that solution. So we're going to be using what we learned on Tuesday, the molar conversions, as well as the molar mass that we learned on Monday. And we're going to include something new, which is the molarity equation. That equation is going to be the number of the molarity is equal to the number of moles divided by the liters of the solution. So if you guys see that triangle, if you guys remember from density, we talked about this triangle once before with density. But if you cover up the one you're looking for, it helps you set up the rest of it. So for molarity, if you're solving for molarity, you would cover it up, and which means you have moles divided by liters to solve for molarity. If you're solving for the liters, we could cover that up, and now we're solving for moles divided by molarity, gives us the liters. If we covered up the moles, then we would solve for moles using molarity multiplied by liters. So that's just a helpful way to remember how to solve for each of the three parts, or we can just remember the equation right here, molarity equals moles divided by liters. Okay, so let's do one practice problem together just so we have an idea of what's going on. And then all the rest of them should be very similar, just making sure that our units are always in moles, molarity, or liters. So if we look at this one, it says how many grams of potassium carbonate will make 200 milliliters of 0.25 of a 2.5 molar solution. So we are given a lot of information. The first thing we're told is that we want to find the grams. So anytime it talks about grams and molarity, we know we're going to have to do some sort of conversion from grams to moles or from moles to grams, which means we have to find the molar mass because they talked about the grams. So that means we have to figure out the formula for potassium carbonate. For this one, we know potassium is K with a +1 charge. We also know carbonate is going to be CO3 with a -2 charge. That means when we have our formula over here, we get K2CO3 as we need 2 potassiums to balance out the charge of our carbonate. When we solve for this, we are going to find each of our 3 molar masses. So we find potassium to be 39.10. We find carbon to be 12.01, and we find oxygen to be 16. Because we have 2 potassiums, we got to multiply this number by 2. We have 3 oxygens, so we have to multiply this number by 3. If we do that and we solve by adding the 3 numbers together, we end up with 138.21 grams of K2CO3 is equal to 1 mole of K2CO3. So we've come up with our molar mass or our conversion factor that we're going to need later on. Now on to our new subject, so our molarity. So before we can do that, we remember that our units have to be in liters up here. And right now they're in milliliters. So to get those from liters to milliliters, we do have to convert. To do so, we set up our railroad tracks. And we have 200 milliliters. And we put nothing underneath. We know that for every 1 liter, there are 1,000 milliliters, which means if we solve this, we have 200 divided by 1,000, which gives us 0.200 liters, including the correct number of significant figures. Right. Up next, we have to go from the molarity and the liters, we got to figure out how many grams there are. But up here, it doesn't have anything to do with grams. It does, however, have to do with moles. And we know that in the future, we can go from moles to grams using that molar mass. So we're going to use the molarity equation, molarity equals moles over liters, to solve for the moles first. So if we do that, we know that 2.5 molar solution is equal to some number of moles divided by 0.200 liters. If I want to get those, the number of moles by itself, I have to multiply both sides by the number of liters to get them to cancel, which means I'm going to do the 2.5 times 0.200. And when I do that, I get the number of moles is equal to 0.50 with significant figures, moles of potassium carbonate. Now that I know the moles from that molar solution, I can convert my moles to grams. So I need to set up my railroad tracks one more time. And I'm going to plug in my 0.50 moles of potassium carbonate on the top left. I'm going to use my molar mass to figure out my grams. So I have moles on the top on the far left, which means I need moles on the bottom on the right. And if I have moles on the bottom right, I need grams on the top right, which is 138.21 grams of potassium carbonate. I'm going to multiply my 0.50 times my 138.21 to get my value of 69 with correct sig figs grams of potassium carbonate. The rest of those problems are just like this one, but solving for a different variable. So you're either solving for your moles, your liters, or your molarity. Just so you guys remember for the future, another name, again, we use for molarity is concentration. All right, so if it says concentration, it's the same thing as the molarity. If you have any questions, let me know. Otherwise, have a great rest of your day.